The next presentation is Dr. Norul Hisham from University of Putra, Malaysia. His title is Bonding Properties of Commercial Scale Woven Oil Palm Sandwich Composite made of urea formaldehyde and phenol formaldehyde resin. So, Dr. Noor, the stage is yours. You can start sharing your screen, please.
Okay. Okay. This is which okay. Can you see my screen?
Yes. So you can go like up to 15 or 18 minutes of presentation, and then we can have like 3 or 4 minutes Q&A.
Okay. So my presentation is a bonding of the commercial scale woven oil palm sandwich composite made of urea formaldehyde and phenol formaldehyde resin. Oops. What happened? Oh. Sorry, there's a problem there. So I try again. Okay. Okay, then okay. Okay. So I start my presentation with the introduction. Sustainable Forest Management (SFM) is used by the Forestry Department of Malaysia to ensure a constant supply of wood for Malaysia wood-based industry. With the SFM, the available cutting rate of the forest resource is reduced, and total log production has been declining over the years from 42,870 hectares per annum during the 8th Malaysia Plan to 36,940 hectares during the 9th Annual Plan in Peninsular Malaysia. So to overcome the wood supply issue, alternative material are needed to be recognized as a substitute for forest natural resource. Oil palm biomass, which is abundantly found in Malaysia, is seen as the feasible option. To date, Malaysia is the largest producer of palm oil after Indonesia. The rise in this industry has caused the total oil palm plantation in Malaysia to expand from 4.85 million hectares in 2010 to a massive of 5.9 million hectares in 2019. Malaysia reportedly has an excess of 365,414 hectares of oil palm tree over the age of 25 years. Okay, with the rise of oil palm plantation over the years, it is expected the waste produced by the plantation will be increased as well. Oil palm trunk (OPT) is one form of the residue and waste produced by the oil palm industry. However, the OPT has a few weaknesses, such as poor in strength, inconstant dimensional stability, low durability, and machining characteristic. Okay, the objective of this research is to determine the internal bonding of woven oil palm sandwich composite fabricates using urea and phenol formaldehyde resin. The second, to determine the internal bonding of woven oil palm sandwich composite for different sandwich type and different glue spread rate. Okay. Detail of the methodology is a patent filing number PI 20177026003. However, in general, the process is started with the preparation of the raw material, oil palm trunk, peeling, trim and cut of oil palm veneer 4 feet times 4 feet, oven dry to 4 to 6% MC, waving the oil palm veneer manually with hand, soaking in low molecular weight phenol formaldehyde, a drying of woven mat and veneer, then hot press single layer veneer and single layer woven, then glue spreading using the UF and PF, hot press at certain time and temperature, then cutting specimen into specific size, and lastly for testing. So for experimental designs, so actually I'm using the two types of glue spreading. First, 300 gram per square meter UF and PF, and second is a 500 gram per square meter for UF and PF. Okay, so here I fabricate 8 types of the woven sandwich composite. With a WO is a woven outer for the outer of the OPT, and WI is from the woven inner of the from the inner part of the oil palm. So I have 8 types of different sandwich composite. First, woven, non-woven, woven, 3-layer. Second, non-woven, woven, non-woven. Third one, woven, woven, woven. Fourth one, non-woven, non-woven, non-woven. WI is for the inner part of the trunk. WI, woven, non-woven, woven, non-woven, woven, non-woven, woven, woven, and non-woven, non-woven. And after that, I testing the internal bond using the MS standard 1789 using the Instron machine. So this example, I made a commercial scale 4x8 of the oil pump trunk. I cut into the strip and woven manually, then submerge into the low molecular weight phenol formaldehyde and leave it a certain time, then hot press. So this example of the final product of the woven oil pump sandwich composites. So this is type 1, 2, 3, 4, 5, 6, 7, and 8. So result and discussion. This is the summaries of ANOVA. So I can say that the type of composite influence the IB for PF glue, but not for the UF. The split rate give significant to IB for the UF, but not the PF glue. And type of composite and glue spreading give not significantly different either UF or PF, but the resin itself gives significant to the IB either UF and PF. So the result of discussion, the type 4 UF bonded resin consists of non-woven outer trunk, has the highest internal bond, 180 megapascal, followed by type 8, 134 megapascal, and type 5, 132 megapascal. While the type 3 UF bonded resin consisting of woven sandwich composite had the lowest internal bond, 57 megapascal. And so for the PF, the type 4 PF bonded resin consists of non-woven outer trunk, has the highest internal bond, 180 megapascal, followed by the type 8, 134 megapascal, and type 5, 132 megapascal. While the type 3 PF bonded resin consists of 3 layers of woven sandwich composite had the lowest internal bonding, 57 megapascal. So overall the PF bonded sandwich composite 136.4 megapascal had a significantly higher internal bonding than the UF bonded, which is 107.51 megapascal sandwich composite. Okay. Overall, the internal bonding with 500 gram per square meter spread rate of UF bonded, which is 130.16 megapascal, sandwich composite is significantly higher than the 300 gram per square meter, which is 85.31 megapascal spread rate of sandwich composite. However, the internal bond is not significantly different for the spread rate of 300 gram per square meter, which is 146.40 megapascal, and 500 gram per square meter, which is 126.27 megapascal in PF bonded sandwich composite. For conclusion, the type 4 for both UF and PF bonded composite had a highest internal bond. This is followed by type 6 for UF and type 5 for PF bonded sandwich composite. Overall, the PF bonded sandwich composite has the highest internal bonding than the UF bonded sandwich composite. The UF bonded sandwich composite with 500 gram per square meter had the highest IB than those with 300 gram per square meter. However, both spread rate is not significantly different for PF bonded sandwich composite. So this is my reference. Then this is a furniture made from oil palm sandwich composite, 3-layer, woven, non-woven woven, and rattan cane. This is a copyright number AR 201-800-6901. So you can see here from the photo, it's an exhibition in Malaysia in Maha. In Maha, it's a Malaysia Agriculture and Horticulture International Conference in Serdang. So the top table here is the woven oil palm composite. This seat and the back seat is also from the woven oil palm composite. This is the window frame from woven oil palm composite. This is a concrete molding from woven oil palm composite. And this is the book rack or shelf made with mixture of woven oil palm sandwich composite. Okay. So with that, thank you very much for my presentation. If any question, just ask me.
Thank you so much, Professor
Very
Hisham,
fast. Yeah.
for this insightful presentation. And I love it so much, the final slide with all the products. I mean, it gives real life context to this work. So we have one question so far in the chat. I will just read it. So Dr. Anthony Adeniji is asking, how did you pick the formulation? Do you carry out preliminary tests before the final formulation?
Yes, we do many initial study for this product. Okay, we start with the ERGS grant or exploratory grant. Then now is we proceed with the prototype research grant. So this now is a stage of prototyping, and then we make the product and we go to some exhibition. There's a few very good feedback from the visitors. There's a few people want to buy this product from US or from Malaysia. Okay, so but now in the future, we will go for the commercial grant for this.
Okay.
So this anytime is almost 5 years research for this.
Wow, wow, great job. So we still have 2 more minutes. Any other questions? If anyone wants to ask a question, please raise your hand. Otherwise, I have a question. So, I mean, it looks really nice, those woven panels, but I mean, do you think that there might be some way to make those panels in in an mechanized way?
Yes, I think yes, because at this time we do manually by hand, but if for commercial scale, we get somebody to sponsor to make a machine to woven this because now for 4 feet by 4 feet it take about half an hour to woven. So if we have a grant to make a machine, then it must be 5 minutes, 10 minutes to woven 4 by 4. And we not woven 4 by 8 because we already try. 4 by 8 is very difficult to woven. It's too big. That's why we shortened it to 4 by 4 feet. And this is suitable for, it gives a very good quality.
Yes. So I also may suggest one thing. There is a commercial product from bamboo. It's called woven stranded bamboo used in flooring. So they do not interlace. So like the different the 0 and 90 degrees. There's no no interlacement, but rather they are placed on top of each other, like layer by layer. And they are glued together. So this might be like another way for getting over this manual labors process. Or there's another company in, I think it's in Holland. They are making, it's called the Cobra Textile or Cobra Text. They are making, I mean, they claim that they make mats from woven bamboo sticks or strips. And they claim that they are making it in like a mechanized system. So, but I don't know what's the process, but perhaps you might be able to visit their website, learn about what they're doing, can get some inspiration.
Yes, Dr. Madani, actually in Malaysia, in Faculty of Engineering, my friend also did for the woven bamboo composite. Woven bamboo composite. I think the woven bamboo composite is not new. It's began in China in 1998.
It's true.
And now, but as you know that when we want to produce something, that the resource must be a very good available resource. Last time in Malaysia, we have 2 factory doing the glue laminated timber, bamboo laminated timber, 2 factory. But after a few years, because of the material is not sufficient, then it's the production is closed. That's why in my mind, everything, the material must be very good in supply, in quantity.
Yeah, true.
So like oil palm, as you know, Malaysia oil palm, uh, we every year we have about a few hundred trunk, a few 100,000 trunk, So the material is ready for supply for industry. For the bamboo, in my opinion, Malaysia need to establish the plantation, because we cannot go rely on the natural resource in the forest, because the transportation cost to the deep inside the forest is much higher. That's why in Malaysia last 5 years there's a green technology exhibition. The Malaysia bamboo board is about 350 per square meter, but the China is only about 250 to 300. So it's different about 50 US dollar per square feet. So that's as a scientist, I always advise myself, as a scientist, we also have to look the what's the cost,
commercial aspects.
the cost, yeah, because it's not we just do research and at the end it's stop at the middle of the road. It's not good. Yeah,
Yes.
very. Yeah, that's
Thank you
my
so
opinion.
much.
Thank you very much. Yeah.
Yes. Thank you. Thank you so much.